So the only two we had to put down are A and B. Cool. Let's go down. Using the graph to determine if each statement is true or false. So we're using this graph right here. This graph represents a function. Well, I could do that vertical line test, but I'm hoping at this point you're kind of getting the idea of the vertical line test, but let's do it anyways. We can drag this line across and we will only hit one part of the line at a time. So we know that it is true. The domain of the function is only positive real numbers. Well, our domain are all of our x values, and if you can see, it dips over here, which is negative, so that is not true. The range of the function is all real numbers greater than or equal to 1. Well, you can see that our range can also be 0, so that is going to be false. The function is continuous. Yes, it is, because it's not specifically just points. We have a line here. We have an inequality that we could set up. So this is true. It is a continuous function. You know when it's discrete when you just have points. So let me scroll up here. This graph right here is discrete because we just have points on our graph. Okay, 5. Graph A, B, C, and D, these all represent continuous functions. This graph right here represents a discrete function, okay? This graph right here represents a continuous function, okay? So let's kind of scroll down. Hopefully that makes sense. 7, is the domain of the function represented by the data shown in this graph discrete or continuous? Well, I'm hoping that because we just did that question above, that you are seeing that this is a continuous graph because it's a line. You can make an inequality. And then which real-life problem below best fits the data? So let's read through these. It costs Y to purchase X songs online. Well, if you buy one song, it will only cost a specific amount. It's not going to cost a wide variety, right? So I is not it, or 1 is not it. Let's look at 2. The depth of a puddle at distance X from its edge. Well, that would work, right? We could have a depth using in that distance with the edge. So 2 would work. The speed Y of a car after time X. Yeah, right? We could slow down. We could be at, 35 miles per hour and slowly slow down after a certain amount of seconds. So yeah, 3 would work. The weight of an apple with a radius X. Yeah, right? We could start at a certain weight, and as we change that radius or cut that apple in half or change that radius, our X could also change. So yeah, 4 would also work. The only one that is not a continuous question in this or answer is that first one. That is a discrete answer. Okay, hopefully if you have any questions on that, let me know. Let's kind of scroll down here. All right. Linear functions. So remember, linear functions are, for one, if your equation, again, has the exact same idea as y equals mx plus b, okay, it is a linear function. So looking at A, y equals mx plus or minus b. Therefore, this is a linear function. Y and x completely stand on their own. They're not getting changed. They don't have exponents. So A is a linear function. B, y equals x cubed plus 3 or plus 1. Right off the bat, because it has this exponent, B is not an answer. So I'm going to cross this out. Oops, it's not it. Do not answer that. C, y equals 2x minus 4. Well, again, x and y are completely standing alone. They don't have exponents, and it's written in the y equals mx plus b form. This is, in fact, a linear function. Let's go down to 2. Which of the following represents a linear function? Select that, apply. Well, linear functions in graphs, they're going to have straight lines. So A is not a linear function because there's 2 lines. It's not completely straight. So A is not a linear function. All right, let's cross that out. No, this is not it. Okay. B, or let's look at all of our graphs now. We're looking at straight lines. C is a straight line, so C is a linear function. E is not a straight line, so E is not a linear function. It has to be a straight line. So C is the only graph that is a linear function. So let's go ahead and look at tables now. Well, remember that tables, we are looking at constant rates of change. They both have to change at a constant rate, adding or subtracting. So that means adding or subtracting. So 3 to 4 is changing it by 1. 4 to 5 is changing by 1. 5 to 6 is changing by 1. And 6 to 7 is changing by 1. So our x's work. Let's check our y's. 8 to 4 is changing by 4, 0 to 4, or 4 to 0 is changing by 4, but then we go back up. So it's not a constant rate of adding or subtracting. So this is not a linear function. B does not work. Let's look at D. 2 to 4, changing by a positive 2, 4 to 6, changing by a positive 2, 6 to 8, changing by a positive 2, 8 to 10, changing by a positive 2, so that would work. Okay, let's check this one. 3 to changing by 4. So let's check this one. 7 to 11 is also changing by 4. 11 to 15 is also changing by 4. 15 to 19 is also changing by 4. So this is a linear function. Woo! Okay. And last one, let's check F. 1 to 2 is changing by 1. 2 to 3 is changing by 1. 3 to 4 is changing by 1. And 4 to 5 is changing by 1. So that works. Let's check our other side. This is changing by 1, 1 to 2, but then it changes by 2, and then it changes by 4, and then it changes by 8. So this is not a linear function because it does not have that same constant rate of change. So only C and D are linear functions. Let's scroll down, complete the table so it represents a linear function. So we need to make sure that this is changing by a constant rate. So it kind of looks like if we jump by 5, so that would be 0, this would be 5, this would be 10. That would give us a linear function, so that would work. You're just making a constant rate of change. Okay. 4, the table shows your earnings in dollars for working X hours. So 35.50. So let's kind of check our rate of change first. So 56.50 to 67. It looks like they are adding 10.50 each time. So this one will be 45, because 35.50 plus 10.50 will give us 45. So there you are. Let's go down. Okay, so we've done a lot of these function notations. If you have an F equation, you're plugging in the F. If you have a G equation, you're plugging in for G. Okay? In this equation here, we know that x is 2, so everywhere you see an x, replace. 2 plus 3, we are going to get 5. Here, we know that x is -3, so go back to the F equation. -3 plus 3 will give you 0. Let's go to C, finding G. So now we're looking at the G equation. And x is 10, so -3 times 10 is going to give you -30, minus 1, you're going to get -31. D, find G of 2. So again, we're going back to the G equation. X is getting replaced by 2, so our x is 2, so replace x with 2. -3 times 2 is going to give you -6. -6 minus 1 will give you -7, okay? You're just replacing your x's that is given to you into the correct or corresponding equation. Let's go down to 2. Use a graph of f of x to complete all parts. So f of 2, so our x is 2. What will y be? Because remember, f of x is y. F of 2 is y. So when x is 2, let's look at our equation over here, or our graph. When x is 2, y will be 3. We're just going up the graph wherever y hits, okay? Find all values for x such that f of x equals 6. So when f of x is y, is 6, what's x? So let's look at 6. X would be -4. Look where it's hitting. So when y is 6, x is -4. Let's scroll down and answer these questions using the same graph. The domain of the function, so looking at x's, our x's here, is -4. Well, that is the least possible x, so far so good. Is less than or equal to x, is less than or equal to 2. Well, our largest x is 2, so that works. That is a true statement. Let's highlight it. Let's look here. When f of -2 equals 6, is that true? So when our x is -2, our y is 6. So let's look. When x is -2, our y is 6. Well, that's not true because it hits at 3. So this is false. The domain of the function is all x's such that 2 is less than or equal to x is less than or equal to 6. Well, we know that's false because we already solved our inequality piece. So this is going to be false. The range, looking at our y's, the range of the function is 2. So let's look at our least possible y. It hits right here. So our least possible y is 2. Is less than or equal to y is less than or equal to 6. Well, our highest x that's possible is 6. So that is a true statement. Boom. That is it. If you have any questions on any of this, please let me know. Have a great day and be prepared for Thursday.